here's a rather hard-looking problem. You're given this function f of x not as a formula but as a graph. It's made up of 1, 2, 3 lines, and it's passing through 0, 2, 1, 3, 2, 2, and 3, 2. And now you're defining this g of x, which looks pretty complicated, right? 3 times f of 2x plus 1 minus 4, and you have to draw this graph. Now, one way to go about this would be actually figure out the equation for this, but that's going to be really hard because it's a piecewise function. So this will be like y equals to x plus 2, but if x is before 1. This will be, I think, y equals to 4 minus x, with x being between 1 to 2, and then the last one will be y equals to 2. So you have like three different definitions for the function. So it'll be very confusing if you try to do it that way. It's not impossible, but it'll be very hard. So let me try to introduce to you the second way. You just have to know where these values, these points, this 0, 2, 1, 3, 2, 2, and 3, 2 is going to be sent in this new graph. And if you can track those, then you can just connect them by lines, just like how this is connected, and that's it. So that makes things easy. Okay. So let me explain by what I mean by that. So first of all, let's look at the graph and fill this table in. At x equals to 0, what's the value of f? 2. At x equals to 1, what's the value of f?
Somewhere between 2 and 3.
No, 1, 3, right? So you know the value is 3. When x is 2, f has the value of 2. And at 3, also 2. Okay, so that makes it a bit convenient. All right. And then, because I know that when x is 0, it gives you 2. To use this value, what you want to do is you want to think about when this is equal to this 0. You get what I'm saying? So take that thing inside the f, and this is very similar to the way we were doing when we were trying to draw the graph of sines. We took the function inside the sine, and we just took that as equal to 0 and then 2 pi. The same idea. You want to see when this is equal to 0 and when this is equal to 1 and 2 and 3, because if you know those points, then you can identify where those points go. Okay. So we said 2x plus 1 equals to 0, which is negative 1. So what's the value of x?
Negative 1/2.
Negative 1/2. So that is planted right here. Negative 1/2, right? Negative 1/2 is the value where if you plug in here, you get 0, and you end up evaluating f of 0, and f of 0 is 2. But then when this f is 2, what's the value of g? What is it? 2 times 3 minus 4, what's that?
2.
2. So that's 2. Okay. Can we do the same thing for 1? Yes. Set 2x plus 1 equals to 0. No, not 0. 1. This thing now should be equal to this number. Right? So what is 2x equal to? 0. So x must be 0. So when x is 0, let's track what happens when x is 0. When x is 0, then this becomes 1. What's f of 1 according to this table? F of 1 is 3. So when this is 3, what's 3 times 3 minus 4?
9 minus 4 is 5.
5. That goes here. Okay? All right. I hope you get the point now. What do I do next? 2x plus 1 equals to? 2. So 2x must be 1. X must be 1/2. But when x is 1/2, this entire thing becomes 2. F of 2 is 2. 3 times 2 minus 4 is again 2. Okay? And 2x plus 1 equals to positive 3. 2x is equal to 2. So x is equal to 1. So when x is 1, this is f of 3. F of 3 is 2. 2 times 3 minus 4, that's 2. So that's what you get. Okay. So you see what I'm doing, right? Okay, now let's try to draw the graph from the table. Here's negative 1/2, comma, let's say 1 and 2. This is 1 point. And then 0, 5, 0, 5. There's 5, this point. And then 1/2, comma 2. So again, this point. And then 1, 2. And then you just draw this shape passing through these 4 points. And that's it. Do this, this, done. Okay? Alright, I guess, no, don't you want to do another example like this one?
Yes.
Okay. What? Yes.
I'm confused on how you got the 1/2 from.
1/2?
Yeah.
Set this 2x plus 1
No.
equals to this number 2.
Never mind.
2x is, if you subtract 1 both sides, you get 1. So you get
Half.
1/2. So that's 1/2. Now let's track what happens if x is 1/2. 2 times 1/2 plus 1 minus 4. Let's track this value.
That's 2.
3 times f of
2.
2. What's f of 2?
Half of 2 is 2.
2. Done. Oh, no. Sorry. F of 2 is 2, so 3 times 2 minus 4, that is equal to 2. Okay, well, maybe having the graph might be confusing, so let's just do this with the table. Okay, so from what's given here, I know that the graph of y equals f of x should be passing through 1, 5, 3, negative 1, 10, 3, 50, 2. And this could be a graphing problem if I'm also presenting the graph. And you have to figure out where those points go under this formula, right? And then once you have those points, you can draw the graph. But since graphing part can be done later, let's just focus on how to fill in the table for that. You have a question? No? Do you want to try this, or should we do it together? Together? Okay. All right, so how do I know what to put here? I want this thing inside the f to be 1, right? So what do? I want the 1/2 x minus 2 to be equal to 1. And that gives you 1/2 x equals to 3. So that x is? No, you multiply by 2 both sides, you get 6. So 6 goes in here. But then, so this is one thing. But then, when x is 6, let's try to evaluate what g of 6 is. G of 6 is equal to negative 2 times f times 1/2 times 6 minus 2 plus 3. And then negative 2f, what's 1/2 of 6? 3. 3 minus 2 is 1. And it should be giving you 1 because that's how we found the number 6. If you plug in 6, you better be getting the 1, right? So that's not a surprise. Now, what is f of 1? 5. Which is
13.
negative 10
Plus
plus 3, which is
negative 7.
negative 7. So negative 7 goes here. Okay, can you quickly try to do the next one? See if you can do it.
Times one, we could just do it.
Hmm?
Times one, we could just do it
Is it because you don't want to work?
It's not that, but time's going, so I'll just do it.
All right, you have 1/2 x minus 2 equal to 3. So 1/2 x is 5, so x must be 10. If I evaluate g at 10, that's going to be negative 2 times f of
3.
Well, I could plug in all that, but it's going to end up being 3, right? Is that okay?
Yeah.
But if you plug in 10, you're going to get 3 for the inside. Okay, what's f of 3? Negative 1. So what's that?
2 plus each 5.
5. So this is going to give you, 10 will give you 5. 1/2 x minus 2 equals to 10. Gives you x equals to 24. 12 and then you multiply by 2, that's 24, right? And then g of 24 is going to be negative 2 f of 10 plus 3. What's f of 10?
F of 10
Is 3 plus 3, so it's going to be negative 3. So when x is 24, it'll be negative 3. Okay, finally, if you have 15, there'll be 17, and then 34 is what you get. G of 34 is going to be negative 2 times this value here, plus 3. So it's negative 4 plus 3, which gives you negative 1. So when x is 34, you get negative 1 as your answer. Okay? That's all.